and I am the co-head for controls or programming department on the RoboRavens robotics team. Okay, for the RoboRavens robotics team. And right now, what we are going to do is give a bit of a short-ish Java crash course for everybody who doesn't necessarily know Java so far, because that is the programming language that we use for robotics on this team. If you already know Java and you're watching this, you don't need to. Like if you took CSP or sorry, if you took CSA or you know Java from previous things, then you don't really need to take this and would rather skip to a later video. But for everyone who does not know Java, then you're welcome. We will teach you from the very beginning. Now, we'll do introduction and setup. So, we will later use an IDE or an integrated development environment that is called Android Studio for Java for robotics coding, but right now, just to show everything off, we are going to use the onlineide.com. And also, for anyone unfamiliar, Java is a popular programming language that is used for mobile apps, desktop apps, web apps, and in our case, for robots, also for Minecraft. That's very important. But let's go back to this onlineide.com. So, what you're going to do is go to your browser and type in online IDE. The first result should then be online IDE code editor, compiler, and interpreter, which is just what an IDE is, and you will get this. So, now, what you're going to do if you're at this step is to go to this Python 3 drop-down menu and click Java. This is very important. It should change this to what we have here right now. And if you don't do that, then nothing else will work. So now we will continue. All right. So this will be this main.java file that you should have just opened is the is where you code everything, essentially, until later. So you'll be coding everything within that. Now we will talk about structure. So Java structure and syntax. Java structure and syntax. Now, all code that runs in Java must be within a class or within a file. Where it says main.java, that is where all your code has to be, in one of those files at the top. Now, like most programming languages nowadays, Java is case sensitive, which means that, let's say, this main and this main, so this one is capitalized, this one is not. If they are both capitalized or both not capitalized, they will no longer work and get confused with each other. And every program must also contain a main method, which is what we are going to use. So, if we go back to here, everyone can see that here it says main.java and this says public class main. This is equivalent to this. This is just saying everything within these curly braces, the ones that light up whenever you click it, will be within this file, essentially. Now, where it says public static void main, this is a method, which we will explain what that means later, but where it says public static void main string double brackets args in this format, this is the main method. This is the code that will run when you click the run button down here. So if we run it now, it'll run this line of code. So it will system.out.println, meaning it will print a line of text that is within these parentheses and within these quotation marks, being welcome to online IDE, happy coding. So that is exactly what we have here. And just to show how this works, you must keep the quotation marks because they are very important for Java. But if you just do hello, welcome to RoboRavens, and just run that. This will take a while because it is online after all. But we will then do hello, welcome to RoboRavens. So then that's basically the first coding you would have done, presuming you are new to Java coding. So that is sort of the real basic syntax of Java. So everything that you want to run when you click the run button has to be within this public class main header of the file header, and within this public static void main, the curly brackets after that, this one and this one, it has to be between those two if you want it to run when you click run. And also the public class main, it has to match the file name. If it doesn't, then it doesn't recognize it as the file. So just remember that. All right, so let's go down to the print method, which we just did, but I'm going to have you do it without showing you. So this print line method, I'm sorry it is long, the system.out.println, but you have to write the whole thing every time. Just copy and paste it. But you're going to add a second print line method, and you're going to make it print something else out. So I'm going to want you to pause the video right now and do that. It shouldn't take that long. It says here time 2 minutes. Honestly, this should take about 30 seconds. And pause it. All right, if you just did it in our back or if you just skipped it, that's fine. I'm going to do it now. So we just quickly go in, grab that, copy and paste it, and now we will delete what's in here and say, hi, my name is Liam, which is my name, or you can put your own name if you're following along with this specifically. So we do, hi, my name is Liam, and then that will print out both, hello, welcome to RoboRavens, and hi, my name is Liam, because we used the println function, which means print line. So it will tab over, it will press return on the keyboard, it will tab over the line after you do it, and then it will print the next line on the next line, which is a bad way of explaining it. But if we then change this to say print, which is also a function in Java, then it will print both on the same line of text. So that should be explanatory. Let's see. Yeah, it prints both in the same line of text. So that is how print line works. Print line / print. All right, let's continue. So let's go on to data types. These are the foundational concepts of Java. I'm going to presume everyone here knows what a variable is, but a data type is just the sort of type of variable. So data types are either primitive or non-primitive in Java. So the primitive data types are the ones directly built into the language that are just stored as themselves, basically. They're stored as numbers, as letters, as a yes or no value, a 1, 0 value in binary. And these data types are int, long, float, double, boolean, char. Or you'll get to know what each of those mean at some point. So, but yeah, the data types, they're built into the language. They just work as values directly, as substitutes for values. But non-primitive data types work a bit differently. These are created by the programmer, or they're imported directly through import statements by getting libraries, by grabbing somebody else's code, something like that. Except for string, which is built into the language but is still a non-primitive data type. And these are objects, for lack of a better word. They store more data than primitive data types. Strings can store basically an infinite amount of characters in a string. And arrays are similar. Classes are basically everything that you'll be making, objects in Java. And these work differently, though. They are stored in a different way, which you don't necessarily have to know specifically how they're stored, just know that they're stored differently, and they store more data. All right. So, oh, wait, that's not right. All right, so let's look at the different data types. So, we will look at integers first off. This is the simplest data type. It is just a number with no decimal. So, to create it, you do int mynum equals 5 for floats, or actually we will be using doubles in our because they are longer, but floats, which are another data type, which are integers but with decimals. Floating point numbers is what they're called, but just having a decimal point and something after that makes it a float. Strings, which we talked about before, which is what the print line takes. So that's just text. Strings are just anything stored as text, but they have to be stored with 2 quotation marks around them. That indicates that it's a string. Booleans, which have either a true or a false value, a 1 or a 0, and they have the keywords stored in them, true or false, all lowercase. Char, which is one character of a string, basically, any character. And this is stored with single quotes or apostrophes around it, as opposed to double quotes for strings, slash regular quotation marks. And a double, which is basically the same as a float, but it's longer, it stores numbers that are 15 to 16 decimal digits after them, as opposed to a float, which is just 7. So we will generally want to use doubles because they are more precise. Um, and yeah, so let's talk about variables. So these data types are types of variables. A variable is a container for storing data values. And as you might have seen before, they have the data type space the variable name with an equal sign equal to the value you will set it to. And as we did not cover yet, but at every line in Java that doesn't have a curly brace after it has to have a semicolon after it, because otherwise the compiler doesn't know that it's an end of a line, and so it'll just treat it as the next line. But variables are containers for storing data values, and there are many different types of variables, and they are based on different data types. And in Java, you have to specify the type of variable you are creating before you do it, which is different from languages like Python, which are higher level languages in that they abstract away more of the sort of signatures and programming language syntax that C-based languages have, like Java, such as the data types. And normally this would be a challenge or a lesson sort of that you do yourself, where you create your own variable using one of the data types and then print it out. But I don't think that we have covered it in enough detail right now. If you believe that you have you understand how to create a variable in Java, then go ahead and do that. But I'm going to do it right now to exemplify it. So let's just delete this, and then let's get a new variable. So we'll just make an integer to start. So we'll do int, which is the keyword. Let's just call it x. That's a pretty good variable name. Int x equals 5. And then just to make it a bit more, we'll do string, which has to be capitalized, unlike the primitive data types. Non-primitive data types, like strings, have to be capitalized. We'll do string Bob equals, and then in quotation marks, Bob. And then what we will do is, let's just get let's just type it. System.out.print line, and then we'll put x, and then we'll grab that line, copy and paste it, and then so actually in Java it doesn't matter if it's the white space if it's tabbed over, because that's what unlike Python, that's what these do, the curly braces. So we can just put this one over here and it's not going to change anything in the compiler. And then we'll just do Bob. And now this is, if you're following along, if you run it now, it'll print out 5 and then Bob. It'll also print out hello, welcome to RoboRavens before that. And, these aren't on different lines. Well, that's fine. Oh, wait, what? Oh, sorry. I just exemplified a big mistake I just talked about earlier, where I did not put a semicolon after my lines. So that is one thing you must always remember, and check your error messages. They'll generally tell you what your problems are. So here you go. Yeah, you have hello, welcome to RoboRavens, and because this is print instead of print line, it prints out the 5 right after it, and then it prints out Bob on the next line because this one is print line. So now you would have printed out both your variables. You could have done that by yourself, but that was just an exemplifying of the simple concepts of Java. So let's move on to variable operations, which are slightly more complicated, but shouldn't be too hard to get either. So what we've already done is declaring and assigning a variable, which just means setting its value, basically. set. So the first time you use a variable, you have to put the signature for it, the data type signature. But after that point, you don't need it because the program already knows what that variable is, other than the first time you create it. So we're going to use that by let's delete where we print out Bob and just start using X. So we will just go and do X equals 3. We're resetting the value, and then we'll print out X again. I'm going to put it in the correct line because it looks better, but it doesn't matter for the actual code. But we'll set X to 3. And I didn't put a semicolon on. Sorry about that. I've been coding in Python recently, so it's I need to get back on my Java. But yeah, so now it'll print out 3 here. So X is 3. We can also do a complicated way of setting, which is X equals X plus 3, which will increment the current value of X to equal X plus 3, which is 8 in this case. So if you take X as 5, as it is here, it will do 5 plus 3, and then save that into X, and then that will become 8. So this value is saved as the product of this value. And then you can also do that with multiplied, like with a asterisk, or divide with the slash, or minus with a minus sign, or other mathematical operations as well. This will be 15, 5 times 3. But there's actually an easier way of doing this as well, other than X equals X times 3. If you are doing it something in exactly this sort of syntax, X equals X operation a number, then you can do multiplied X equals 3, or plus X, or minus X, or divide X equals 3. That's actually, I'm not gonna, no, we'll do that. We'll talk about that right now. So if we do X divide equals 3, it will divide X by 3, which equals 5/3. But as this is an integer, it can't save decimal points, so it'll truncate it, meaning it will just remove all the decimal points and save it as 1, because 5/3 is just 1.66. So it'll just remove the 66 at all and turn it into 1. And then it'll print it out, so it's just printing out 1 here. Now, let's see. Do we have anything else? Yeah, we had compound assignment. Yes, increment and decrement. So let's quickly do this. Is if you want to increment something by 1. You just do a x plus plus, being the variable name plus plus with 2 plus signs. You can also do an x minus minus, which will decrement it by 1, which will lower the value by 1. And if we run that, it'll just print out 2 and then 1 again, because it adds 1 to it, or plus plus is adding 1 to it, and then it decreases it by 1 again and saves it into itself, so it'll print out 1, which is back to the value it was before. So, that's interesting. That probably shouldn't be taking that long. Alright, I'm stopping that. I'm going to do myself a quick favor and remove this, anything that might get in the way, and then I'll just run it again. Okay, I did it again. Okay, sorry about that. I should probably probably add my copy and paste of system.out.println to actually equal the semicolon at the end. That would maybe help us do this a bit quicker. But there we go. So it's 5, which is its original value. It turns to 1, which is this. It turns to 2, because it's incremented by 1. It turns to 1 again, which is decremented by 1. So that should be the entire thing here. Also, we should talk about string concatenation. So, let's say we wanted to say x to indicate that's the number. We would put a string there. If you remember using the double quotes or the regular quotation marks, we would put a space and then a plus and then this. This is the syntax for string concatenation, being to create a string out of multiple different values. They can be anything. One of these values, though, has to be a string. So you have to have a string and then add anything, a boolean, a float, a double, an integer to it. It'll work. Maybe another string, it'll just add them together in a line. So, and then if we were to save that into a string, it would save x colon space 1 as into the string. And we already did print. So also quickly, we'll talk about this. So on this line, oh, whoops, sorry about that. On this line, we see right here, it is int age and then a semicolon because you always need a semicolon. All this is doing is creating the variable. It's setting age to an integer data type right here, but it's not setting a value yet. So it'll wait to set a value to here. The int age equals 25. So now it's 25, and then if you print it out, it would just be 25. But here, it sets it to the default value, which for an integer is 0, and for the double, it's 0, and all these things have default values, but generally you don't need to use them. But just remember, you can put these on two different lines if you don't want to create a variable with a value directly. So, oh yeah. So, quick, we did kind of just do this, but I'm going to want you to do another practice where you maybe create another variable. Let's make y or j or something, and use 3 of the operations we talked about so far, and then print it out. So, and then pause the video and come back when you've done that. All right. I'm not going to go through and show you necessarily that because we did just do it, but this would have been good practice for you to do. But I just did this with x. So, all right. So we talked about booleans before, but now what we're going to talk about are the actual uses of these booleans, which are logical operations. So a logical condition in Java. Logical conditions rather in Java compare 2 or more values and return a Boolean result based on the truth value of the input. So that's a bit complicated to say, but basically, presumably everyone here would know what A is less than B means. Everyone knows what or this is a greater than. Anyone knows what a greater than, a less than is. Presumably, and then a greater than, less than or equal to, and a greater than or equal to as well. These should be known, and what they do is these are operations that return or are equal to a true or false, a Boolean, a true or false value based on if they are true. Based on if A is greater than B, then this will return true, and if A is less than B, then this will return false. And then also the equal sign. So as it says here, in Java, a single equals and a double equals are not the same. So single equals sets the variable or whatever on the left of it, so closer to the edge where you write, the left of it to the value of anything that's on the right of it. But equals equals checks if the two values on either side are equal to each other, and if they are the same, it will be true. It will return true. Not equal to, which is an exclamation point equal to, is also the same. It's just the opposite, exactly. So it'll return true if these are different, if these two values are different. And then less than or equal to and greater than or equal to you should probably know them from math, I would assume. So let's put these into practice. Let's just go here and let's not have this. Let's just create a Boolean value that is called D. Let's just do it. And let's do D equals x is greater than 5. So, as we know here, x at this point is equal to 2, so this will be false. But, and then if we print out D, then we run it, it will print out false here. I did not put a semicolon again. Sorry, this is a real problem I have at this point. Alright, so it prints out false here, lowercase, remember, lowercase false. And this should be pretty simple because you would have done this in math. X being 2 is not greater than 5. And then if we turn this around, and let's just say it's a less than or equal to, doesn't change it here, but if we just do that, then that will make it so it is true, because 2 is less than 5. That should be pretty obvious. Yeah, it'll be true here. And then, if we go in and put let's say, if x equals 2, this will make it true again, because x is 2, and it'll print out true. And then if we do x is not equal to 2, this will print out false, because x is equal to 2, so this is the only value in the integer spectrum that will return false here, but it will return false because x is equal to 2. And then these are creating Boolean values, so those are logical operators, but we have more as well. So these are very important logical operators, but they aren't as mathematical. So these are and, or, and why does this say equal to? This is meant to be not. But we have and, or, and not. So the AND operator is using double AND signs. It is double in Java for whatever reason. Single AND signs are not used, but these are double in Java. So both A and B must be true. It takes two statements, or maybe two variables, two values, and checks if they are both true. And if they are, it returns true as a whole. The whole operation returns true. But the OR is pretty similar, but it is more inclusive. It returns if A or B are true. So if A is true and B is false, the whole thing returns true. And if A is false and B is true, the whole thing returns true. And then if they're both true, it still returns true. The only time OR is false is if both values that go into it are false. And then equal to, this is not equal to, and then the negating operator, so the not, as it's generally called, is just an exclamation point. If you put it, parentheses still work with logical operators. It is like normal math. So if you put parentheses around a logical operator, such as if you did A and B or A equals B, it will exactly flip the resulting value. So if A and B are the same, so this would return true, it returns false because there is a not here around it. But if they are not the same, and it would normally return false, this would then return true. It just flips it. And now we will talk. Okay, wait. We should probably exemplify these somewhat. So let's just go ahead and put parentheses around this, and then put a not out front, which will flip the original statement. So if x is not equal to 2, it will return false instead of true. So here it returns false because x is equal to 2, which means that this inside would be false, but on the outside it is true because it is flipped. And then let's say we keep piling on, so we take this already to mean true, and then we put an and then we do and let's let's just do a simple one. And false equals true. This should be, it's false. So false does not equal true here. So this will return false because both of these have to be true. Exactly. But if we change this to equal to an or, which is the straight up line, which should be underneath backspace on your keyboard, um, if we do that, then this will be true because this right here we already know to be true, but false is not equal to true. So this is false, but it doesn't matter. Only one of them has to be true. And that will print out true. So let's get back into arithmetic operators. So we already kind of talked about these. So these are just addition, subtraction, multiplication, division, and one that you might not have heard of, which is modulus. So this is remainder division. So it divides the two numbers. So it divides A by B. So like this right here. So let's say A is 5, B is 2. This would be 2.5. If we do dividing 5 by 2, but with modulus, it divides the 2 and then returns the remainder. So to divide 5 perfectly into 2, you have to remove 1 from it. It has to be 4. So that means the remainder, modulus, here, this returns 1 because you take away 1 from 5 to make it 4, divide it by 2, it equals 0. The remainder from doing that is 1. And so this would return 1. Now, I'm going to want you to do what we did before with x, but make a second variable. This one can be y, or if you already have a y, do a, b, c. Literally any name can work. You can call it Gibrati spatula, and it'll still work. But I want you to make two variables which are each equal to a number. They should be integers just to make it simpler, but just do that. And then use an arithmetic operator on them and print it out. So any of these sort of things. They don't have to be A at B, just replace the name A, B with a variable name, and then come back to me once you have finished it. This should take 3 minutes. Alright, so I guess I'll demo it. So let's, I'll quickly do so if you highlight this is called a comment. If you then click Control and then slash, being the slash under the question mark on the keyboard, Control slash, it will put a double slash here, which you can also just type a double slash, which will then comment out these lines, meaning that they won't get picked up by the by when you run it. These just no longer, effectively they don't exist, but you don't want to delete them because you want them still to be there, but they aren't going to run anymore. So if we then go in and make d, let's just make a b equals 10, and then we do d equals 10, and then I'm just going to use modulus. Sorry, not 10. It's the same, but you would want 10 mod x, and then print out d. So this will print out because x here is equal to, hold on. I have a serious problem, probably. All right, so now we have, oh, whoops. Sorry about that. Forgot remember, check your error messages. So we have okay, I did it twice. I've been coding too much in Python. I think I may need to take a bit of a brain freeze to undo the damage that has been done by Python. Anyways, it prints out 0. So this should print out 0 because you're doing 10 mod 2, because 10 is divisible by 2. It has no remainder, so it's 0. You can use this as well to check if something's divisible by 2 if you just do that number mod 2 and then do an don't run this, but an equals 0. It'll check if it's 0 if you set this to a boolean, and then it will now print out true here because oh wait, this will not yeah, no, it prints out true. So that's a way to check if something is even or odd, because if it's odd, it'll be false, and if it's even, it'll be true. All right, so now let's get on to conditionals. This will be the last lesson of this video, but there will be more videos later for doing the more complicated parts of Java. So, conditionals. If you know what an if statement is from other programming languages, it's that, essentially. So, a conditional is, but if you don't know what an if statement is, because that's the general term for this, but if you don't know what an if statement is, then I will explain it. So, conditionals, or if statements, are statements that allow programs to perform different actions based on whether a condition is met, which is a true or false value. This is Boolean. These are the Boolean operations that we used before, the logical operations, but they are used to actually as logic in the code. So basically, it's if whatever is in the parentheses is true in an if statement, or evaluates to true, then something will happen. Then whatever is within its curly braces, whatever is after it, will happen. And then if there's an else after it, then if whatever in the curly braces evaluates to false, then it'll do that instead. So, how does this work? Now, an if statement is used to specify the block of code, and then an else statement specifies the block of code to be executed if the first condition is false, and that's if it's true. We will exemplify this real quick by just doing a quick rewrite where we do if, and then we put in parentheses this, remove the semicolon, and then just do that. And let's put that here. So what this does so far is if this evaluates to true, so if b mod x is equal to 0, so basically if b is because x is 2, if b is an even number, then it'll activate this, and else sorry, that's not the right, we'll do else, and then we will do a system.out.println, and then we will just print out odd number. There we go. And now if we run it, it'll print out D, so it'll print out true. It'll print out true. So if we, what? Oh, it's B. What? Also, D doesn't even exist. Hold on. Let's just print out even number. This is why it's better to not repurpose code you just use for something else, for a new thing, and just write new code. But we have even number, prints out that, so that should be fine. Now, that is an if statement. You just printed out something because the condition was true. That could have been printed differently if the condition was false, which I should show probably. So, if we just put a different condition here, we just go ahead and put a put new parentheses around it, and then put a not sign or an exclamation point, then you can see that it'll print out odd number instead. Just by the fact it's not an odd number, it just flipped whatever's in here to equal false, so an else happened as opposed to the if here. So now these are continued conditional statements, so I'm going to let you work with these, but the else if statement is used to specify a new condition to test after an if. So basically you are chaining if statements. So your first if is if the condition is true. Your second if is if you want to test a second condition given that this condition did not activate. You test a second condition. Then you have another else if. Then you test a third condition. Then you have an else to see if none of these conditions were true. It will print out this. So I'm going to want you to, given what I just explained before, the if statement I just put quickly before, you will print out what grade you're in depending on your age using the if conditionals here. So let's just say you give like ages of, you have conditions going down of if your age is 13, if it's 14, if it's 15, if it's 16, if it's 17, if it's 18, although I doubt that. But that's what this assignment is to do. So make an if chain to determine if what your grade is, and then you will print out your grade. So you get 5 minutes for that. So pause the video and do that, and then come back. All right, so let's hope you did it. If you didn't, I will show it. And if you did, you can check your work. So let's quickly go in and just make a variable int age. I will just, sorry, that's not how you do that. Age, you'll do int age, and then we'll do equals, I'll just do my own age, which is 17. And then we will have an if age equals, let's say, 14, and then I will copy that here. Then we'll do else if age is equal to 15. We'll change the print statement at some point. Then we'll do a else if age equals 16. And let's do 17, and then we'll have an else here, which just prints out you are an unk, because if you are above 17, you are, obviously. And now we change this to be, we have 14 equal to freshman. I know this isn't technically a grade level, but it effectively is. Sophomore, junior, and senior. There we go. That's not how you spell senior. Senior. And then if we run it, for me, it'll print out senior here because I am 17, so I'm a rising senior. And here, it prints out senior. So whatever you put, depending on whatever your age is, it will print out something different, but let's hope you have code that looks generally like this. Here, maybe with some slightly better use of space, like that. But let's hope you have code like that. So pause to check it, and then that should be pretty good. Now let's look at, all right, so while loops are are something that we will do in the next video. So if you want to take a break, go ahead, but we are ending right